Uh, Hello to everyone. My name is Alejandro Hernandez. I'm a robotic engineer at Robotics, and today we'll talk to you about the robot Blockly package, programming ROS with blocks. It's the first time that Robotics has a talk here in the ROSCon, so let me tell you some words about our company. At Robotics, we aim to simplify robots and artificial intelligence creation, and to do so, we build the next generation of artificial robotic brains. So if you have interest about this work, please don't miss the talk about my colleague, Victor Mayoral, which is going to present today our last relevant work about the hardware robot operating system. So let's start with the presentation, and I would like to start talking a little bit about our experience teaching robotics. And for several weeks, we talk different groups going from high school to PhD level and how to make use of our robots. While most of the people quickly understand the different mechanical part of a robot, understand the underlying software is something that took quite a bit of effort. And when making our training season, one of the first things we try to introduce is the concept of ROS. While there are many resources of this topic, it is a fact that learning ROS takes some effort, so we start prototyping some ideas to make this process as simple as possible. So this makes us to look into systems like Scratch for robot programming, and the output of these prototypes has become Robot Blockly, a multi-platform web-based tool for programming robots and drones that use ROS. But we are going to start step by step, and first of all, this work has been inspired by Scratch, which is a visual programming language. This means that we are not going to see any code. We are only going to program with blocks. So Scratch was designed in 2003 as an educational programming language by the MIT. And Scratch is primarily designed for 8 to 18-year-old, but it's also used by people of all ages. So this is Blockly, which is the second word of the package. And Blockly is the efforts of Google to transform Scratch in a web-based application. So it's allowed with pages to include a visual code editor. In our case, we are going to use Python because it's fully supported by ROS and also by Blockly, and we don't have to compile any code. So this is Mitch Resnick, which is the creator of Scratch, and he thought that we shouldn't think about young people as digital native. So young people spend most of their time using new technologies. So they are really comfortable and familiar browsing, chatting, texting, gaming, but it doesn't really make you fluent with new technologies. So young people have a lot of experience interacting with new technologies, but a lot less at creating and expressing themselves with new technologies. As we can see in this picture, people normally text and use technologies. It's almost as if they could read, but not write. In robotics, that really means that they need to be able to write their own computer programs or code. So now I want to launch a question. How many people here is fluent in Korean? Okay, anyone? How many people here is fluent, in Spanish? Okay. How many people here is fluent in Python? Okay. As I expected, most people here are able to speak or to be fluent in a programming language than in a foreign language. For example, in Spain, we normally learn English as the second foreign language, or one of the first foreign language, the second language. So in other countries, so the third language normally is French or Germany. But nowadays, makes sense that learn a new this third language as a programming language, for example. So increasingly, people are starting to recognize the importance of learning how to code. For example, the New York mayor, Michael Bloomberg, is taking coding classes nowadays. And the Estonian government has started teaching the first grader how to code. And normally people think coding is like this, and in fact, if this is what coding is like, it will be only a narrow sub-community of people with special mathematical skills and technological background that can code. But we need to engage new people in programming and in programming robots. So by using Scratch, or in this case, Robot Blockly, people are able to become fluent with new technologies. They are able to express their ideas with them by programming. So for this reason, we have created Robot Blockly, which is a ROS package that allows users to create ROS-based algorithms and behaviors, abstracting its complexity using blocks. The aim of this package is to hide the complexity of programming robots, via functional blocks. So, So this is Robot Blockly. As you can see here, we have different buttons just to launch the code or save or load your blocks. And if we click this button, we can see the blocks. These first blocks are in general blocks like variables or these things, so maths, loops, functions, and so many things. Okay, it's just quite simple to use these blocks. It's just only dragging and moving the interface, right? And in the top of in the below of the image, we can see the supported robots, and in this case, we can see the blocks that, for example, stand up, early spider, okay, or for example, early brain that contain calibration for the sensor, or just different kind of algorithm, like start different 2D lasers or SLAM algorithms. Okay. So if we take a look to the architecture of Robot Blockly, we have two different sides. In one side, we have the front end, which is the interface, as I showed you in the last slide, which is write all in JavaScript and HTML. And in the other side, we have the backend, which contains the logic of the application. And this logic is going to understand the blocks that we have created in the front end and substitute this block by Python code, or in this case, ROS code. And we have two main folders. One is blocks, which contain the shape of all of the blocks that Blockly contains. And the other one is generators that contain the Python code of which is going to be linked with the block. And if we think about the workflow, it's just simple. Yeah, we only need to build our own blocks, just dragging and moving blocks. We are going to launch, we're going to click in the button, and the block is going to send back to the logic with a WebSocket. And the logic is going to take care about everything, the ROS node, topics, action, or whatever. And the backend all the time is sent to the front end, the state of the block. So we are be able to see which block is executing each time. So if we take a look to the structure, okay, let's move this here, okay, of Robot Blockly. Okay, I have my fork here of the code, right? So it's a common ROS package. You can see the cmake list.txt and the package.xml. Here the main folder is the front end. So here we have Ace builds. This package is write on JavaScript and is able to highlight the code in the browser. And also the Blockly folder is the blocks generator. So if we go to the blocks folder, we can see here the different robots that early rover, early spider, early brain. So we open one, for example, early rover. You can see the license, right? And you can see the JavaScript code that generates the shape, right? So this is quite simple. In the following slide, we are going to see how can we create this kind of things. And in the generators folder, we can select the the programming language. In this case is Python scripts. And also we are going to select rover again, and for example the mode. So this is the code that is going to be substituted by the block that change the mode of the rover. As you can see, is ROS code is quite simple, and I think it's really easy to create your own blocks. Okay. So if you would like to create your own blocks, you don't have to know about JavaScript. If you don't know, we have an interface. It's the same as Blockly. You can drag and move different blocks to the definition box. And in the preview, in the top right of the image, we can see the preview of the block that we are creating. So in the language code, we are going to see the JavaScript code that we have to include in the blocks folder. And the last one box, the generator box, is going to be your ROS code. You have to write there your ROS code and include in the generator file. So I have some recommendation for you. The first one is to use ROSPy, wait for message, because you have to be sure that we have to receive the data from a publisher in the code block. So if we use callback, we are not completely sure that you are receiving data in this code block. And also you have to check all the thing about ROS is if the ROS node is launched and the topics, because the user that use the front end don't care about the ROS. Okay, so let's see what can we program with Robot Blockly. So in this example, we got a spider with other brain in the top with a camera. So we are going to show the red color to the spider, and the spider is going to turn to the right or to the left if the spider sees the color. So you can see how the code with this executing is highlighted, and also with, I don't know, 20 or 15 blocks, we are able to create a behavior. Not so complete, but enough to move a spider. So in this other example, we have a spider again with a 2D laser, and we create an algorithm to move around a maze. So again, you can see that with only 20 blocks, we are able to move the spider. So just imagine that just in 1 day or in few hours, you are able to move a spider using ROS. So you don't know nothing about ROS, but you are able to move spiders or to move robots in this case, and I think it's really cool. So in the first 2 blocks, we can calibrate the IMU of the spider and also start the laser of the spider. So just few blocks and just to move a robot. And the last example is a little bit more complex, and just is executing also the same algorithm that we have before in the other example, but now we are able to create an SLAM algorithm. So the interface of Blockly allows you to see the map that the spider is generating. So again, with few blocks, just adding the green loop, we are able to create the map. So in yellow, you can see the initial position of the spider, and in the purple curve, you are able to see the path of the spider in the world. Okay. So to conclude my presentation, this kind of package make it easy how to teach robotics, and also make accessible robotics for people who don't have programming skills. So make it easy this enter on this wall. And many people can ask me, okay, there are so many other solutions to program with blocks, and I say yes, but for example, LabVIEW or Simulink, but they are not easily extensible, and also are proprietary, so that means that you have to pay a license, and Robot Blockly is free. So nowadays, we are not the only one who build their own Robot Blockly blocks. There are companies like Seoul Robotics building its own blocks to move their manipulator, these hand manipulators. And I think one of the most important things here is the license, which is open source, license under GPL version 3. So if you have interest on this, you can force the code and start prototyping your ideas or prototyping your blogs to make this more bigger. And if you don't have the bandwidth or if you don't have the knowledge to do this thing, you can reach us out or hire us to help you during the process. So are you ready to jump into robotics? Become a roboticist programming with blocks. Thank you. No question? Everything clear?
If I have a custom robot, how can I mean, not like your spider or something, how can I use this interface? I mean,
Okay. Can you speak a little bit louder?
If I have a custom hardware, not the hardware listing it, can I input a model inside it?
That you would like to include your own robot, you mean?
Yeah.
It's quite simple. You only have to fork the code and just build your own blocks. So I explained that you have the code, so the blocks and generator files. So you only have to include your code in these two folders and just include your own hardware.
Oh, so no need to mapping like the I/O between the blocks and the interface.
Can you speak louder, please?
No need the like mapping the I/O between our robot hardware and the blocky. I mean.
So you can include the robot that you would like. You only have to program your hardware.
I make my hardware and using this.
You can build your hardware or your robot, and you can include in Robot Blockly. You only have to include the section of your robot and make the pull request to the main repository.
Okay. Thank you.
Hi.
Hello.
I was curious on the interface you had with the mapping. What other kind of extensions might you have where you can visualize the representations of information to the student or to the user? Are you using what machinery are you using for that?
So the question is that how
you're exposing some of the topics or messages?
No, we are not exposing the topic. We only expose the information that is useful for the user. For example, in the case of the SLAM, you only see the map and the position of the robot. So you don't know nothing about the topics and this thing because it's hidden because of the blocks.
Is that done in the browser?
No. Topics and nodes are not exposed in the browser.
Oh, okay. I was just talking about the visualization.
Because the people or the person who write the blogs have to take care about topics and nodes. The user don't need to know about this.